Hello everyone. So in the previous video, we saw the approach that used three pointers to solve the question 3 sum closest. In this video, we will be implementing the solution in JavaScript. So without further ado, I've set it up for you. Let's discuss what we have and then build up on it. So we start off by initializing our first pointer at the very first index, that is index 0. Then we have two variables to store the closest difference that we'll continuously calculate and the closest sum that we'll continuously calculate as well, which will eventually become our answer variable. And then we have the length of the array. Now the confusing part would be here. I understand that. So let me explain that for you. So the closest sum has been kept as an arbitrarily large value because we'll be calculating this value again and again and again, and we keep on checking, right, whether the sum that we've calculated so far and the difference is it smaller than the closest difference and the sum that we have so far respectively. So I say that this value should be large enough to cover all the possible closest differences, because for example, if I had initialized it at, let's say, 10, and one of the closest differences while calculating would have turned out to be, let's say, 3, we wouldn't have updated our answer in that case. Sorry, would have turned out to be 11, right? We wouldn't have updated our answer in that case because 10 is smaller than 11 and 10 would be closer, right? So we have to keep this value large enough so that it covers all the possible answers that we can have for this variable. Now, what makes me think that this is a large enough value? For that, I see the constraints over here. It says that the target is 10 to the power 4, and that is the largest value that it can have. The smallest is its negative counterpart. Same goes for the element, that is, it is minus 1000 to plus 1000. So our actual largest closest difference would be 10 to the power 4 minus of 1000. Right? And so I've taken a value that is comfortably larger than this right here, so that we have our answer intact. Now, we have to start off with our loop. So the first pointer, it goes on all the way till the end, right, to the very last index. So whenever it reaches the nth position, which is the length of our array, we have to exit this loop. Now in this loop, whenever we start or restart this particular loop, we decide what to do with our second and third pointers. So our second pointer, P2, would be right next to P1, and third pointer would be at the very end. The last index would be at n minus 1 position. Now, we have our pointers in place, so we start our second loop to actually start testing out our combinations. So while P2 is less than P3, and again, this condition is no different than what we discussed in the previous video. So if you haven't seen it yet, I suggest you do that first. So while the second pointer is still before P3 and not overlapping in any way whatsoever, we start our process. So we start off by getting all the elements and summing them up. So our temporary sum would be at our respective pointers. We have our elements and we sum them up. Now, we have to calculate the difference that we have for this combination with respect to our target. So the temporary difference for this combination would be target minus the sum that we just received. Now I mentioned that the sum has to be absolute so that the value is kept as positive for the difference, and that makes our calculation easier, right? So this absolute function is what we'll implement now. In this function, we pass a value. We can of course use an inbuilt function for this, but it's quite simple, so I'll just implement it to make it simpler and to have you see exactly how it goes. So if this value is less than 0, we will simply multiply this by -1 and return it. Otherwise, we return the value as it is. All right. This will make our sum as a positive value. Now, we have our difference. We need to find out, firstly, whether this difference is 0 or not. If this difference is actually equal to 0, we don't need to do anything else. We simply have to return the temporary sum because this is the best possible case that we have. But if this difference, temporary difference that we have, if it is less than the closest difference that we have so far, this variable right here, then we update the closest difference to this new difference that we've just calculated. And of course, if this difference is closer, that means the sum would also be better for us than the previous answer that we had. So we update it. Which will be our sum. All right. Now, how do we update our pointers? That is the question, and the answer is very simple. We take our second pointer, we of course check first if this sum is less than our target or not. If it is, that means we want the sum to be bigger so that it can be closer to the target. For that, we already discussed this. The second pointer needs to move forward by one place, but we also want to avoid duplicates. So we check if the second pointer is less than, while, not if, while the second pointer is coming before the third pointer, and the value at the new second pointer, the updated second pointer that we've updated just now, and this value is the same as the value at the previous second pointer, which means we are at a duplicate combination. We move the second pointer once again. We do something similar for the third pointer. For the condition, if this sum happens to be greater than our target, then we move the third pointer backwards. And we check this condition that if the third pointer is ahead of the second pointer and the third pointer happens to be the same as the third pointer that was previously, we move it another place backwards and keep checking it. And once we're done updating, we continue because we want to test out the next combination. All right. Now that should cover our inner loop. As far as the outer loop is concerned, how to move the first pointer forward, that is, we simply move it forward. And of course, we avoid duplicates by checking that this pointer should be in the valid range and its previous value should not be the same as its newer value. If it is, we move it forward by one other place. One more place, sorry. And that is what we do over here. All right, I think we should be good to go. We of course we need to return our answer as well. So when all is said and done, at the very end, we return our closest sum. Let's try to run this. Of course, the most important part, we did not sort this array. So let's sort it right at the beginning. And I did this in the previous video as well. There's implementation of sorting. So if you don't know what this means, go right ahead and watch it. And I think we are missing another thing over here, and that is, of course, some of you have even caught it while I was writing it, that we need to compare it to the previous value, not the same value naturally. Okay, our answer has been accepted. Let's try to submit this. All right, our answer has been accepted. It's a pretty good solution. And that is how you solve the question 3 sum closest. Thank you so much for watching and follow for more.